adjustments in the denture's fabrication. When scanning the maxillary arch for edentulous patients, ensure the intraoral scanner's smart color filter is turned off to accurately capture the delicate soft tissue details. Begin with stable regions like the hard palate, moving towards dynamic areas while maintaining a consistent distance and angle with the scanner to capture the full arch. For the mandibular arch, it's just as important to disable the smart color filter for clarity. Start scanning from immovable tissue areas and proceed to the more flexible regions. Special attention should be given to capturing the buccal and lingual sulci accurately, as these are critical for proper denture fit. Both processes require careful scanning of the alveolar ridges and the buccal and lobular vestibules, ensuring all pertinent anatomical features are clearly recorded for the subsequent design and fabrication of the denture. The use of a centric tray in edentulous cases begins with the clinician positioning it within the patient's mouth to record the preliminary vertical dimension and jaw relationship. The tray is equipped with impression material, and the patient is guided to bite down, allowing the material to capture the contours of the edentulous ridge. This provides an initial estimate of VD and a starting reference for centric relation, which is then refined through subsequent appointments to reach the final. In this video demonstration, we show the scanning process of a centric tray that has captured the impressions of both the upper and lower arches of an edentulous patient. The procedure starts by scanning the impressions in the tray to get a digital record of the bite registration. After the initial scan of the impressions, we focus on scanning the lateral sides of the tray. In this video demonstration, we guide you through the process of aligning the scan data of an edentulous patient's upper and lower jaws using a centric tray. The key step shown is the inversion of the tray scan to correctly align the mesh directions of the scans. This crucial technique ensures that the upper and lower jaw scans are perfectly matched in orientation. In previous video, we demonstrate how to capture the interarch relationship for edentulous patients using a centric tray and oral scanning. We enhance this process by employing a simple yet effective intermediary cotton rolls, which serve as a bridge connecting the upper and lower jaws. By adjusting the fit between the arches. We demonstrate how to design an individual tray compatible with the Nathometer and using Medit software. We begin by launching the Medit design software and importing upper and lower jaw models. After virtually extracting teeth and smoothing the areas, we proceed to Medit splint design application to set the insertion direction and adjust the interior offset to the maximum 0.5 mm while minimizing others to avoid retention features. We then draw and finalize the splint margins. The same process is repeated for the mandibular model. Afterward, we run Medit design again to combine the splint with the jaw scans, adjust the rim mesh by referencing facial scan data, and remove any extraneous flat areas. By adding a 1 mm offset to both jaws and subtracting from the rim offset, we complete the integration of the rim and splint. The final step merges the splint and rim to complete the tray design. This slide visually details the progression from design to assembly of a dental device. On the left, the top and bottom images display the 3D printed individual tray created as previously described. The center images capture the tray after attachment to the Nathometer M, illustrating how the components fit together. On the right, we see the complete assembly, showcasing how both components integrate to form the final setup used for capturing precise dental impressions. In this video, we demonstrate the process of taking impressions using an individual tray for denture fabrication. Initially, adhesive is applied to the tray to ensure the impression material adheres properly. We then apply a heavy body impression material around the borders of the tray for the primary impression, capturing the detailed contours of the edentulous area. Following this, a light body impression material is spread over the entire surface of the tray for the secondary impression. This two-step process ensures a comprehensive and precise capture of the dental anatomy, resulting in a detailed and accurate final impression. In this video, we demonstrate setting the vertical dimension and determining the centric relation using the Nathometer M. We begin by attaching the Nathometer M to the setup and adjusting it by turning the screws to set the appropriate vertical dimension. Once the vertical dimension is set, we proceed to adjust the mandible by moving it forward, backward, and side to side. This maneuver helps us accurately determine the centric relation.